The engineer's voicemail was 2 hours old when the bridge fell. "We found some cracking, but from a safety perspective we don't see this as a concern," he told the Florida Department of Transportation. 6 people died under 950 tons of concrete while that message sat in someone's inbox, unheard, unread, and completely ignored. This is the story of how accelerated bridge construction became accelerated bridge destruction. How a university's pride project turned into a rush-hour execution. How the people paid to keep you safe decided a traffic closure wasn't worth the hassle, until it was worth 6 lives. The celebration lasted exactly 5 days. On Saturday morning, March 10, 2018, 950 tons of concrete and steel hung suspended over 8 lanes of Miami traffic. The FIU pedestrian bridge, all 174 feet of it, was about to make history. And it would. Just not the kind anyone wanted. The bridge had been built adjacent to Southwest 8th Street using a method called accelerated bridge construction. ABC, they called it. Build the entire span off-site, move it into place during a 6-hour road closure, minimize traffic disruption, maximize efficiency. Florida International University was proud of this approach. The school literally hosted the federally funded Accelerated Bridge Construction University Transportation Center. They were experts. Or so they claimed. Meanwhile, the bridge itself represented something unprecedented in engineering. A concrete truss design that had never been attempted before. Not once. Nowhere in the world. Most bridges use redundant support systems. If one member fails, others take the load. But this bridge used a single plain concrete truss. One line of diagonal members running down the center. If any critical member failed, the entire structure would collapse. The National Transportation Safety Board would later note that concrete truss bridges are exceedingly rare. Translation: nobody builds them because nobody wants to risk catastrophic failure. But FIU wanted something special. Something dramatic. The design included a fake cable-stayed tower, purely for aesthetics, that would make the bridge look like it was suspended by cables. It wasn't. The cables were decorative. The entire 950-ton span was self-supporting, held up by those concrete diagonal members. And one of those diagonal members, number 11, was already doomed. The installation that Saturday morning went flawlessly. Self-propelled modular transporters, massive hydraulic platforms, lifted the bridge span and rolled it slowly across the highway. Crowds gathered. University officials gave speeches. News cameras captured the spectacle. In 6 hours, the span was in place, resting on piers at both ends. A Florida International University press release declared it a milestone in the university's history. They had no idea. The problems started immediately. By Monday, March 12, workers noticed cracking at the north end of the bridge. Diagonal member 11, the critical connection where the northernmost truss met the deck, had developed visible cracks. Not small hairline cracks. Not the kind you might dismiss. These cracks were massive. When engineers finally measured them, they discovered the cracks were 40 times larger than the maximum acceptable width for a reinforced concrete bridge. 40 times. The maximum acceptable crack width in reinforced concrete is typically 0.01 inches. These cracks measured nearly half an inch wide in places. A subcontractor would later call them scary. On March 13, 2 days before the collapse, W. Denny Pate, FIG Bridge Engineers' lead engineer on the project, called the Florida Department of Transportation. He left a voicemail. Listen to the calm in his voice, the confidence of a man who has designed bridges for 30 years, as he delivers a message that will haunt him forever. Hey Tom, this is Denny Pate with FIG Bridge Engineers. Calling to share with you some information about the FIU pedestrian bridge and some cracking that's been observed on the north end of the span, the pylon end of that span we moved this weekend. We've taken a look at it and, obviously some repairs or whatever will have to be done. But from a safety perspective we don't see that there's any issue there, so we're not concerned about it from that perspective. Although obviously the cracking is not good and something's going to have to be, done to repair that. At any rate, I wanted to chat with you about that because I suspect at some point that's gonna get to your desk. So, at any rate, call me back when you can. Thank you. Bye. The voicemail was left on a landline. Tom Andres, the FDOT engineer who needed to hear this message, was in the office that day. But he didn't check his voicemail. The message sat there, waiting, while the cracks grew larger. Meanwhile, the university went about its business. Students crossed Southwest 8th Street at traffic lights. Cars stopped under the bridge waiting for green lights. 60,000 vehicles per day used that road. The average daily traffic. And the road stayed open. Nobody closed it. Nobody thought to close it, because the engineers said it was safe. Thursday morning, March 15th. Spring break at FIU. Most students were gone. But not all. At 8 a.m., FIG engineers climbed onto the bridge deck to inspect the cracks in person. They'd seen photographs. But photographs don't capture scale. Photographs don't capture the visceral horror of seeing concrete splitting apart where it should be solid. According to meeting minutes released later, one engineer noted that the cracks look more significant in person than they did in photographs. No kidding. At exactly 9 a.m., a university employee sat in traffic below the bridge, waiting for a red light at the intersection of Southwest 8th Street and Southwest 109th Avenue. He heard a sound. A loud, whip-cracking sound. Like a gunshot. Like something breaking under immense stress. He looked up at the bridge above him. Saw nothing obviously wrong. The light turned green. He drove away. At that exact moment, 9 a.m., engineers, contractors, and government representatives gathered in a construction trailer on site. The design-build team meeting. Called specifically to discuss the cracks. 12 people attended. From FIG Bridge Engineers, Denny Pate, the lead engineer. Dwight Dempsey, regional director, joining by telephone. Eddie Leon, bridge engineer. From Manila Construction Management, Rodrigo Asaza, project manager. Ernie Hernandez, superintendent. Pedro Cortez. From the Florida Department of Transportation, Alfredo Reyna, coordinator for the FIU Bridge Project. From Florida International University, John Cal, Associate Vice President of Facilities Management. Patrick Maher, Director of Facilities Construction. From Bolton Perez and Associates, the construction inspection firm, Jose Morales, Senior Project Engineer. Rafael Urdaneta, Project Administrator. Carlos Chapman, Construction Engineer. Maria Cristina Acosta, Inspector. 12 people. 12 professionals. About to make a decision that would kill 6 people. The meeting lasted 2 hours. FIGG's lead engineer delivered a technical presentation. He showed photos of the cracks. He showed calculations. He showed analysis. His conclusion, the structural integrity of the bridge was not compromised. The crack did not present safety concerns. The road below did not need to be closed. Someone asked why the bridge was cracking. The FIG engineer's answer, according to meeting minutes, it just happened. Let that sink in. A bridge with cracks 40 times larger than acceptable engineering standards, and the explanation was, it just happened. Fig insisted that no crack repairs should be done yet. First, they needed to stabilize the node by continuing the post-tensioning work. They needed to tighten the steel rods running through diagonal member 11. Pull everything back together. Stop the cracking. Nobody suggested closing the road. Nobody suggested evacuating the workers from the bridge. Nobody raised a life safety issue. The Florida Department of Transportation representative, Alfredo Reyna, sat in that meeting and heard all of this. He raised no objections. FDOT would later state that, at no point during any of the communications did Fig or any member of the FIU design-build team ever communicate a life safety issue. Of course they didn't. Because they didn't think there was one. The meeting ended around 11 a.m. Work resumed. VSL, the post-tensioning contractor, sent workers back up onto the bridge to continue tightening the steel rods in diagonal member 11. Below, traffic flowed. Cars stopped at the light. People went about their day. The clock was ticking. Alexa Duran was 18 years old. A freshman political science major at FIU. Member of the Alpha Chi Delta sorority. The kind of person who lights up any room, any circumstance, any situation. That's what her friends said. She was driving her gray Toyota SUV back from a doctor's appointment. Her best friend Richard Humble sat in the passenger seat. They were heading west on Southwest 8th Street, approaching the intersection with Southwest 109th Avenue. Sitting in traffic. Waiting for the light to turn green. In the car ahead of her, a vehicle driven by a woman whose name was never released to the media. This woman would survive. Barely. She reported later that small rocks fell onto her car just before everything went wrong. Concrete dust. Debris. The first sign of catastrophic structural failure. Above them, 6 workers from VSL stood on the bridge deck, tightening the post-tensioning rods in diagonal member 11. Trying to stop the cracks from growing. One of those workers was Navarro Brown. 37 years old. He had a family. A life. He was doing his job. One of his co-workers, name never released, heard something. Cracking. Not the whip crack sound from that morning. Something worse. Continuous cracking. The sound of concrete failing under load. He moved fast. Locked his safety harness. Clipped onto the safety line. 3 seconds later, the bridge exploded. That's what it looked like. An explosion. Security camera footage from an FIU parking garage captured it. One frame, the bridge is intact. Next frame, it's sagging. Next frame, it's gone. Diagonal member 11, the northernmost connection, failed. The steel reinforcing rods that were supposed to prevent the truss from sliding along the deck sheared completely. The concrete at the nodal connection, where diagonal 11 and vertical member 12 met the deck, simply blew out. With nothing to hold it, the north end of the bridge sagged. Deep. Fast. The diagonal fractured, folded, and the entire 950-ton span dropped. 18.5 feet. From the supports to the road. The dashcam video shows the collapse took a few frames. Maybe 2 seconds. Maybe less. The sound was indescribable. Witnesses blocks away heard it. A roar. A crash. The sound of concrete and steel and rebar hitting asphalt and crushing everything underneath. 8 cars were stopped at that light. 8 vehicles. All in the eastbound lanes. The bridge fell at an angle. Driver's side first. Alexa Duran's gray Toyota SUV took the full force of the collapse. The driver's side. Where she sat. Her friend Richard, on the passenger side, survived with injuries. He tried to get her out. Couldn't. The bridge had crushed the driver's side completely. The woman ahead of her, the one who saw the small rocks falling, felt her car being crushed. Just the front. She survived. Trapped but alive, behind Alexa, Alberto Arias. 53 years old. Dead instantly, Brandon Brownfield. 39 years old. Dead instantly, Rolando Fraga. 60 years old. Trapped in his vehicle. His partner Oswaldo Gonzalez, 57 years old, in the car with him. Both dead. Up on what remained of the bridge deck, Navarro Brown, the worker whose harness didn't save him. Dead. 2 of his co-workers hospitalized with serious injuries. 1 worker who locked his harness in time, dangled from the safety line. Alive. Watching his co-worker die below him. 6 people dead. 10 injured. 8 cars crushed. The 911 calls started immediately. FIU police dispatched 14 units, 33 officers. The Emergency Operations Center opened within minutes. Miami-Dade Fire Rescue, Miami-Dade Police, Florida Highway Patrol, all converging on the scene. And above it all, that voicemail. Still sitting on Tom Andres' landline. Still unheard. From a safety perspective, we don't see that there's any issue there. Orlando Duran was in London when he got the call about his daughter. My little girl was trapped in the car and couldn't get out, he told El Nuevo Herald. She died when the bridge collapsed on top of her car. This is going to be the longest and saddest trip of my life. I don't want to return. Alex's sister Dina took to Instagram. Rest in peace, my sweet little sister. Words cannot describe how heavy my heart is. I would give anything to take your place and all of your pain. George Fraga and his wife spent Thursday night calling hospitals, calling the Red Cross, desperate for information about Rolando Gonzalez. You call the hospital. His name is not there. You call Red Cross. He's not there, Fraga's wife said, emotionally. They waited. Hoped. Until Friday, when the news came. Southwest 8th Street, one of Miami's major traffic arteries, remained closed for 9 days. Not 9 hours. 9 days. While crews worked to remove 950 tons of concrete and steel. While they recovered bodies. While they tried to understand how this happened, Miami-Dade Police Director Juan Perez told reporters, "This is a tragedy that we do not want to reoccur anywhere in the United States." But the question remained, how did 12 engineers, sitting in a meeting that very morning, decide this bridge was safe? The answer was worse than anyone imagined. The National Transportation Safety Board investigation took months. When the final report came out, the findings were devastating. The engineering design error that directly caused the collapse was shockingly simple. FIG bridge engineers miscalculated the resistance to sliding. Let me explain what that means. The bridge deck, the walking surface, was poured concrete. It was allowed to harden completely. Then, the truss members were poured on top of it. These 2 concrete pours created what's called a cold joint. A seam where old concrete meets new concrete. For the bridge to work, the diagonal truss members had to transfer their load into the deck without sliding. They had to be locked in place by steel reinforcing rods embedded in both the deck and the truss. FIG calculated how much force these rods could resist. How much load they could transfer. They got it wrong, catastrophically wrong. The NTSB found that FIG underestimated the load on diagonal member 11 by a factor that made the connection completely inadequate. The connection could handle maybe 1/3 of the actual force being applied. Meanwhile, they also made the problem worse by cutting a 12-inch circular hole in the deck, right at the critical connection point, to accommodate an 8-inch drain pipe. This hole reduced the cross-sectional area of the deck exactly where it needed to be strongest. It made it impossible to install enough reinforcement to transfer the load. In simple terms, diagonal member 11 was trying to push down on the deck with enormous force. The steel rods were supposed to resist that force and prevent sliding. But there weren't enough rods, and the rods weren't strong enough, and the concrete around them had a giant hole cut through it. It was a design guaranteed to fail. The cracks that appeared after installation were the bridge screaming that it was overloaded. The concrete was literally tearing itself apart because the forces were too great. And the engineers, looking at cracks 40 times larger than acceptable, decided everything was fine. But wait. It gets worse. Major bridge projects in the United States require independent peer review. A separate engineering firm examines the design, checks the calculations, looks for errors. It's a safety net. A second pair of eyes. The FIU bridge had a peer review. Louis Berger, a consulting engineering firm, was hired to review FIGG's design. There was just one problem. Louis Berger wasn't qualified. Under Florida Department of Transportation rules, companies performing peer reviews must meet certain standards. They must have experience with the specific type of structure being reviewed. Louis Berger had not been rated as qualified to review a project like the FIU bridge since at least 2013. 5 years before the collapse. That didn't stop them from doing it anyway. A Louis Berger employee told FIG they were qualified. FIG believed them, and the peer review, even if Louis Berger had been qualified, was inadequate. The NTSB found that Louis Berger's review failed to detect FIGG's calculation errors in its design of the main span truss member 11/12 nodal region and connection to the bridge deck. The one job they had, find errors in the design, and they didn't do it. But here's the truly infuriating part. Louis Berger only reviewed the design for the completed bridge. The final configuration with the decorative tower and fake cable stays installed. They never reviewed the temporary configuration. The bridge as it stood on March 10 through March 15, resting only on the two end piers with no additional support. That temporary configuration, when the bridge was most vulnerable, was never independently reviewed. The OSHA investigation later noted, "It is interesting to note that neither FIG, FIU, nor FDOT raised the issue of why the structural design of the intermediate stage was not checked by Louis Berger. FIU and FDOT may not have known that the intermediate stages of construction were not checked by Louis Berger, but FIG knew, because Louis Berger created the scope of work based on the limited resources allocated by FIG. Translation: FIG knew the peer review was incomplete. They knew the temporary configuration hadn't been checked. They paid for a limited review to save money. And they didn't tell anyone. Florida International University had no business managing this project. Let me be clear about that. The university had 0 professional engineers on its payroll. 0. They relied entirely on hired contractors for all engineering expertise. This wasn't a typical Florida Department of Transportation project where FDOT engineers review and approve every step. This was a local agency program project. The LAP, where FDOT delegates responsibility to a local agency, in this case, FIU, and provides only supervisory oversight. FDOT identified the FIU project as elevated risk. Their own internal assessment noted the university had questionable capacity to manage the project. The unique non-redundant concrete truss design added to the risks. And yet, FDOT didn't provide adequate oversight. An Inspector General report released years later found that FDOT division area engineers did not consult the division's bridge engineer to assess risks on the FIU project, which includes a highly complex pedestrian bridge. They did not perform detailed design or calculation reviews. Had they done so, the report concluded, it is almost certain the fatal design errors that the National Transportation Safety Board attributed to FIG bridge engineers would have been detected. How can they be so sure? Because it was FHWA bridge engineers, working for the federal government, who discovered the errors for the NTSB as part of the post-disaster investigation. Federal engineers found the mistakes in days. State engineers could have found them during the design phase. But nobody looked. The university wanted a showpiece. A dramatic bridge that would put FIU on the map. They got the drama. Just not the kind they wanted. Let's go back to that morning meeting. 9 a.m. 12 people discussing cracks 40 times larger than acceptable. Someone should have stopped work. Someone should have closed the road. Someone should have said, "This is beyond acceptable. We need to evacuate everyone and figure out what's happening." Instead, they decided to keep working. Keep tightening those post-tensioning rods. Keep traffic flowing below. The OSHA investigation cited both Fig and Bolton Perez and Associates under the General Duty Clause. Not for violating specific regulations, but for failing to remove their employees from the proximity to a bridge that had developed multiple cracks of significant width, depth, and length at critical locations in load-bearing members of the bridge, which compromised the structural integrity of the bridge. In hindsight, OSHA argued, the cracks were obviously a recognized hazard. But at the time, Denny Pate, the most qualified engineer on site, believed the bridge was safe. He'd been designing bridges for 30 years. His entire career with FIG. Since 1980, right out of graduate school. He dreamed of designing bridges since he was 8 years old, growing up in Alabama, building little bridges across creeks in the woods. He was good at his job. Really good. FIG had designed the iconic Sunshine Skyway Bridge across Tampa Bay. One of the most beautiful bridges in America. In 40 years of operation, FIG had never had a catastrophic failure. Until March 15, 2018, Denny Pate looked at those cracks and made a judgment call. Based on his experience, based on his calculations, based on his understanding of concrete behavior, he decided the bridge was safe. He was wrong. At 1:46 p.m., diagonal member 11 sheared completely. The concrete blew out. The steel rods snapped. 950 tons of concrete dropped 18.5 feet onto Southwest 8th Street. And Denny Pate's career, his reputation, his life's work, all of it crushed under the weight of that failure. He won't be remembered for the Sunshine Skyway Bridge. He won't be remembered for 40 years of successful designs. He'll be remembered as the engineer who designed the bridge that killed 6 people in Miami. That's his legacy now. Forever, 6 people. 6 lives. Each with families, friends, futures. Alexa Duran. 18 years old. Political science major. Sorority sister. The girl who lit up every room. Her father in London, getting the worst phone call of his life. Her sister posting on Instagram, wishing she could take Alexa's place. Alberto Arias. 53 years old. Stopped at a traffic light on his way home. Never made it. Brandon Brownfield. 39 years old. His co-workers told his family he died. His family spent hours calling hospitals anyway, hoping the co-workers were wrong. They weren't. Rolando Fraga. 60 years old. And his partner Oswaldo Gonzalez, 57. Together in the car. Together when the bridge fell. George Fraga and his wife, Rolando's nephew and his wife, spent the night calling everyone, searching everywhere. You call the hospital, his name is not there. You call Red Cross, he's not there. Navarro Brown, 37 years old. Up on the bridge doing his job. Working for VSL, the post-tensioning contractor. Following orders from engineers who said it was safe. 2 of his co-workers survived with serious injuries. One worker who locked his harness in time dangled from the safety line while Navarro died below him. 6 people. 6 families destroyed. Because 12 engineers in a meeting decided closing the road was unnecessary. The lawsuits came fast. 18 civil lawsuits filed against 25 businesses connected to the project. Manila Construction Management, MCM, the general contractor, filed for Chapter 11 bankruptcy in March 2019. Exactly 1 year after the collapse. They reached a settlement with victims and families for $42 million. The company restructured. Changed their name to Magnum Construction Management. They're still operating today. Still working on major projects. Fig Bridge engineers faced citations from OSHA. Not for violating specific regulations, but under the General Duty Clause. The proposed penalty was $25,868. The maximum OSHA is allowed to fine. Let me say that again. 6 people dead. Maximum fine, $25,868. That's what 6 lives are worth in OSHA penalties. Meanwhile, Denny Pate testified in court about his cell phone. The phone that might have contained photos of the cracks, messages about the project, evidence about what he knew and when. Pate's wife, he claimed, accidentally put his pants with the phone in the pocket into a washing machine. The phone was destroyed. No photos, no messages, no call records. The judge was not impressed. I can't tell whether any of this is remotely accurate and what may be out there that Fig hasn't told us about, Judge Jennifer Bailey said. The victims' families eventually received a total settlement of $102.7 million. Distributed among all the plaintiffs. All the dead and injured and permanently disabled. Money doesn't bring back Alexa Duran. Doesn't bring back her father's daughter, her sister's little sister, her friend's light in the room. Money doesn't bring back Navarro Brown. Doesn't restore Alberto Arias, Brandon Brownfield, Rolando Fraga, Oswaldo Gonzalez. It's just money. Paid by insurance companies. While the people responsible moved on with their lives. Drive through that intersection today. Southwest 8th Street at Southwest 109th Avenue. Watch what happens when cars approach the traffic light. Nobody stops under the bridge. The new bridge, finally completed years later, spans the same location. A different design. Properly reviewed. Built by different contractors. But Miami drivers won't stop underneath it. They wait before the bridge, or past it, but never directly under it. Content creator Sanzalo filmed it on his motorcycle. Posted it to Instagram. Look at how nobody stops under the bridge, people are terrified of it. Comments flooded in. The most traumatic day in our history. Too much pain. We still feel it when we talk about that moment. This habit will last 100 years. One woman commented that she drove under the old bridge just 4 minutes before it collapsed. I still avoid stopping beneath any similar structure. I get honked at a lot, and it terrifies me. Another person added, whenever I pass through the area, I offer a prayer for the victims. The collective trauma runs deep. Deeper than concrete. Deeper than steel. A whole city changed by 2 seconds of catastrophic failure. The NTSB's final report listed the probable cause, load and capacity calculation errors made by Fig Bridge Engineers, Incorporated. Contributing factors included Louis Berger's inadequate peer review, FIGG's failure to identify the significance of structural cracking before the collapse. FIGG's failure to obtain an independent peer review of the remedial plan to address the cracking. The report highlighted 13 major failures. 13 points where someone could have stopped this. 13 opportunities to save 6 lives. Number 1, FIGG's fundamental design errors. Underestimating loads, overestimating capacity. Number 2, the inadequate peer review by an unqualified firm. Number 3, FIU's lack of professional engineering staff to manage a complex project. Number 4, FDOT's failure to provide adequate oversight despite identifying the project as elevated risk. Number 5, the decision to use a novel, non-redundant concrete truss design with no precedent. Number 6, the failure to properly review the temporary construction configuration. Number 7, cutting a 12-inch hole through the deck at the critical connection point. Number 8, the failure to recognize that cracks 40 times larger than acceptable meant imminent failure. Number 9, the decision to continue post-tensioning work without closing the road below. Number 10, the failure to evacuate workers from the bridge when cracks appeared. Number 11, the inadequate communication of safety concerns to FDOT. Number 12, the voicemail that wasn't heard until after the collapse. Number 13, the meeting where 12 people decided the bridge was safe, then watched it collapse 5 hours later. 13 failures. Any one of which, if corrected, might have prevented the tragedy. But they weren't corrected. Because everyone assumed someone else was checking. Everyone deferred to FIGG's expertise. Everyone believed the engineer of record when he said it was safe. Tom Andres, the FDOT engineer who received Denny Pate's voicemail on March 13, finally listened to it on Friday, March 16. One day after the collapse. From a safety perspective, we don't see that there's any issue there. Except there was an issue. A massive issue. An issue that killed 6 people while that message sat unheard. FDOT initially claimed Andres was out of the office until Friday. That's why he didn't hear the message. Away on assignment. That turned out to be false. NBC6 investigators revealed that Andres was in the office the morning of March 15. The morning of the collapse. He just didn't check his voicemail. FDOT has no record proving exactly when Andres retrieved the voicemail. They claim he got it Friday. After the bridge fell. Would it have mattered if he'd heard it Thursday morning? Before the collapse? Probably not. The message said there was no safety concern. Why would he close the road? But we'll never know. Because the message sat there. Unheard. While the cracks grew. While the meeting happened. While the workers climbed back onto the bridge. While Alexa Duran drove under the span. 2 hours. The message was 2 hours old when the bridge fell. The irony is devastating. FIU was famous for accelerated bridge construction. The school literally pioneered ABC techniques. They hosted international scholars. Published research. Trained engineers from around the world. And they used those techniques to build a bridge that collapsed 5 days after installation. The whole point of ABC is to minimize traffic disruption. Build the bridge off-site, move it into place quickly, open the road fast. Reduce the time workers and drivers are exposed to construction risks. Instead, they created a bridge that spent 5 days as a 950-ton guillotine over rush-hour traffic. The confidence in ABC was completely eroded after FIU. Not because the method is inherently unsafe, but because this project demonstrated what happens when you combine a novel design with inadequate review with overconfident engineers with insufficient oversight. ABC works when it's done right. When redundant safety systems are in place. When peer reviews are thorough. When agencies provide proper oversight. FIU's bridge had none of that. They wanted to be first. They wanted to be innovative. They wanted their bridge to be a landmark. They succeeded. Just not the way they planned. That university employee who heard the whip crack sound at 9 a.m. waiting at the traffic light below the bridge. He heard the structure failing. He heard the concrete starting to tear itself apart. And he drove away. Because why wouldn't he? The bridge was new. Just installed. Designed by professionals. Reviewed by experts. Approved by government agencies. Of course it was safe. Except at that moment, 9 a.m., 12 of those professionals and experts and government representatives were sitting in a meeting, deciding whether to close the road. They decided not to. 4 hours and 46 minutes later, the bridge fell. The FIU pedestrian bridge wasn't built to fail. It was designed to last 100 years. To withstand a Category 5 hurricane. To be a landmark. A symbol of innovation and progress. But it was built by people who made mistakes. FIG engineers who miscalculated the loads. Louis Berger reviewers who failed to catch the errors. FIU administrators who had no engineering expertise. FDOT officials who didn't provide adequate oversight. And when the cracks appeared, when the bridge screamed that something was wrong, those same people decided everything was fine. They held a meeting. Reviewed the evidence. Made calculations. Delivered presentations. And concluded, with confidence, that the structural integrity was not compromised. 5 hours later, 6 people were dead. This is the story of institutional failure. Of deference to expertise that was wrong. Of assumptions that weren't questioned. Of warning signs that were ignored because the math said everything was okay. Until the math was proven wrong. By 950 tons of concrete falling 18.5 feet onto rush hour traffic. The engineer's voicemail was 2 hours old when the bridge fell. From a safety perspective, we don't see that there's any issue there. 6 families would disagree. Miami still does. Every time drivers refuse to stop under that new bridge, they're voting. Voting with their fear. Their trauma. Their memory of March 15, 2018, when expertise failed and 6 people paid the price. The bridge was built to fail. Not intentionally. Not maliciously. But through a cascading series of failures, assumptions, and mistakes that turned a university's pride project into a mass casualty event. And somewhere, Denny Pate lives with the knowledge that his voicemail, his confident assertion that there was no safety concern, was the last official word before the collapse. The last chance to close the road. To evacuate the workers. To prevent the tragedy. We don't see that there's any issue there. History will remember otherwise.